Lesson 4.3. We did some simplifying, we did some multiplying. Are we ready for example D? Does that sound right?
Yes.
Yes? Okay. So we're going to review multiplying a little bit, and then we're going to divide, and then you guys should have a little bit of work time. Okay? So, if you recall what we were doing yesterday, it's all about the factoring, right? Factor everything you can, and then you're looking for pieces that will cancel. So, with that in mind, we had just come off of example C, which had lots of fun factoring. Okay, so let's move into example D. First of all, if it's not already a fraction, how do we make it a fraction? Okay, that's putting it over 1. Okay, so. Okay, guys, what are we thinking? X squared plus X plus 10. Thoughts on factoring that one? Is there a GCF?
No.
No? No GCF. What are we going to assume? Looks like it should factor into 2 parentheses, yes? If that's the case, what do we need to happen? We need 2 numbers that what? Multiply to be 10 and add to be 1? What numbers multiply to be 10?
1 and 10, 2 and 5.
1 and 10, 2 and 5. Anything else? No? So what pair of numbers works? Okay, we don't have anything that works. So it doesn't happen a whole lot, but it does happen that this is something that doesn't factor. If it doesn't factor, just carry it down as is. So it's going to stay x squared plus x plus 10. And the only way you'll be able to cancel it is if you have another x squared plus x plus 10. Okay, what about x squared minus 49? We factored like several things like that yesterday, yes? Factors into 2 parentheses. X squared breaks into x and x. What about the 49? Yeah, this is difference of squares, so square root of 49 is 7. And since it multiplies via negative 49, we need a plus and a minus. Okay, what about my other numerator? X squared plus 9x plus 14. Does it factor? Yes? 2 parentheses. X squared breaks into x times x. I need numbers that multiply to be 14 and add to be 9. What multiplies to be 14 and adds to be 9? Okay, 7 and 2. If they multiply to be positive and add to be positive, it's both positive. And the 1 in the denominator stays in the denominator. Okay. Is there anything that cancels? What's going to cancel? Okay. 1x plus 7 on top cancels with 1x plus 7 on bottom. Anything else? Okay. Once you've canceled everything you can, then remember, we're multiplying 2 fractions. So you're multiplying numerator times numerator, denominator times denominator. With that in mind, your x squared plus x plus 10 needs to go in a parenthesis because we're going to be multiplying it by something else. So we have x squared plus x plus 10 times the x plus 2 all over x minus 7. Okay, and you could say x minus 7 times 1, but you don't need the extra times 1. And what do you guys remember about restrictions from yesterday? Okay, that is anything that was in the denominator. Any factors in the denominator set equal to 0. So if I use my factored form here, easiest thing to say is x plus 7 and x minus 7. So if I set x plus 7 equal to 0 and x minus 7 equal to 0, what do we know? X cannot equal what? Okay, negative 7, positive 7. If you'd like, you could say plus or minus 7. Okay, that's your choice. I think Savas would be okay with that, but no. So just remember, restrictions is setting your denominators equal to 0. Okay? Okay. Does that review multiplication for you? Okay. Simplifying fractions, multiplying, very much the same. Now we've got one other topic, and that is dividing. Now, okay, dig back into what I think would be middle school brains. How do we divide fractions? Okay. Keep, change, flip is the 3 words you probably know it as. As a math teacher, I'm going to officially do my job and use the phrase multiply by the reciprocal to start us off. Okay, because officially as a math teacher, how do we divide fractions? And that is to multiply by the reciprocal. Okay, so as I said, as a math teacher, I feel like I have to make that statement of multiply by the reciprocal. However, what is the good shortcut that you learned in middle school that you still remember to this day most likely? And that is the keep, change, flip. So I am also perfectly fine with talking keep, change, flip. Okay? So, with that in mind, when we talk about multiply by the reciprocal, okay, if I use that phrase, that means division sign is going to turn to multiplication sign. And we talk about the reciprocal, multiplying by the reciprocal, that means we're always going to take the second fraction. When we talk reciprocal, that means to flip it. So you're always going to take the second fraction and flip it. Now, keep, change, flip is your shortcut. So keep the first fraction, change division to multiplication, and flip the second fraction. Okay? Once you get past that, it's the same as what we've been doing. Now, if you want to factor as you start going, that's fine. I'm going to go ahead and just straight up start with keep, change, flip. So I'm going to keep the first fraction, 3x cubed plus 6x squared plus 3x over x plus 2. I'm going to change division to multiplication, and I'm going to flip the second fraction. So it becomes x plus 2 over x squared plus x. Okay, so there's your keep, change, flip. From here on out, it's the same as what you've been doing on the other problems. No different than the front side of our notes. So thoughts on factoring 3x cubed plus 6x squared plus 3x? Okay, do we see the GCF there? They all have at least a 3. They also all have an x. So we're going to factor out GCF of 3x. 3x cubed divided by 3x leaves with x squared. 6x squared divided by 3x, 2x. And 3x divided by 3x is plus 1. Okay. Am I done factoring on that piece? No, there's still going to be more factoring. I'll get that on my next round. As you set up your own paper, it's up to you how you do it. What about this x plus 2? X plus 2 is just x plus 2. Second fraction, x plus 2 is x plus 2. What about x squared plus x?
Is there GCF?
They both have an x in common, yes. So they both have x involved. So let's factor out GCF of x. X squared divided by x is x plus x divided by x is 1. So x times x plus 1. We're almost done, but go back and grab that other piece on the first numerator of the first fraction. So 3x was already there. What about x squared plus 2x plus 1? Factors into what? 2 parentheses. X squared is x times x. I need numbers that multiply to be 1. Well, right there, multiplying to be 1 is 1 times 1, and adding to be 2. So that's plus 1 and plus 1. Denominator is x plus 2. Second fraction, x plus 2 over x times x plus 1. Okay. What cancels?
X plus 2.
Okay. 1x plus 2 on bottom cancels with 1x plus 2 on top. What else cancels? Okay. Note 1x plus 1 on bottom cancels with 1x plus 1 on top. What else cancels? The x. You remember yesterday, I think we had one that was 4x, and I said think of that as 4 times x. That's the idea here. This is a 3 times x, okay? And you can break up multiplication, okay? That's 3 times x, or just 2 factors. So if that's 3 times x, an x cancels with an x. Okay, that 3 is still there, but the x is canceled. Okay, what remains for a final answer here? We have a 3 on top times an x plus 1 on top over 1. Do I need to write the 1? No, we talked about this yesterday. You could put the 1 if you wanted to, but Savas would definitely count you wrong, so just 3 times x plus 1. Okay? So, dividing fractions, start with keep, change, flip, and then it's no different than multiplying fractions. Now, the one thing we do need to talk about is restrictions. And there is a slight twist on the restrictions that we have to be aware of. How do we find our restrictions? Okay, and how did you say that? Okay, each part of the denominator equal to 0. And if you've listened to what I've talked about between yesterday and today, anything that's ever been in the denominator set it equal to 0. In the past, that referred to anything that might have canceled. We still have to include it. The catch here is we did a keep, change, flip, so we have to look back there too. Now, if we look, I'm going to look at this factored form here. We know for sure there's what? X plus 2 we have to set equal to 0. There's an x we have to set equal to 0 and x plus 1 equal to 0. Now, here's what you have to watch out for, and sometimes it matters, sometimes it doesn't. Anything that's ever in the denominator, those were in the denominator, but also, while this is what we factored in the denominator, before we flipped this fraction, what else was in the denominator? That x plus 2 there. Okay, now, I know down here that x plus 2 is in the numerator, but here's the deal. It started in the denominator. So, and if it makes that fraction, that denominator 0, it makes that fraction not exist. So anything that was ever in the denominator would also be included. Now, in this scenario, if we also set that x plus 2 equal to 0, does it matter in this case? It's a repeat in this case, so it doesn't matter. If it wasn't a repeat, it matters. Fair enough? So what I will tell you is any original or new denominator has to be set equal to 0. Okay? So any original or new denominator. Okay, so what do we know? X cannot equal what? Subtract the 2, and we'll talk negative 2. We've got a 0, And if it's x plus 1, subtract the 1. So x cannot equal -2, 0, and -1. And you can write those in whatever order you want. Order's not going to matter. Okay? So, only trick with division, keep, change, flip, or multiply by the reciprocal officially. Okay, let's look at B. Okay, first of all, what do you notice in B? What type of problem is B? It is a division, yes? You've always got to check that. If it's division, start immediately with multiplying by the reciprocal or keep, change, flip. So I'm going to keep 1 over x squared plus 9x. I'm going to change division to multiplication, and I'm going to flip and make it 3x squared minus 18x over 6 minus x. Okay? Let's go through and get some factoring. 1 is 1. What about x squared plus 9x? Okay, x squared 9x. There's no const at the end, so think GCF. They both divide by x. X squared divided by x becomes x plus 9x divided by x is 9. Okay. Second fraction. 3x squared minus 18x. Okay, yeah. 3 and 18 both divide by 3. And both terms have x in common, don't they? So yes, 3x. When you factor out 3x, we're left with x minus 6. Now, part of the reason I wanted to make sure we did this problem, 6 minus x. Well, here's the deal. Is 6 minus x in the form we normally work with? No, what are we used to seeing first? We're used to seeing the variable, the x first, yes? So let me flip this, and when we flip this, what kind of x is this? This is a negative x and a positive 6. Okay, so if I think of that as a negative x and a positive 6, there's not really anything in common other than this first value is negative. What could we factor out here? We could factor out a -1. And when you factor out -1, that's going to do something helpful, which is why you need to see this. Negative x divided by -1 becomes positive x. Plus 6 divided by -1 becomes minus 6. So if I factor this, this is -1 times x minus 6. Does that matter? It does, because it gives us something to cancel. Now, I wrote mine as -1 times x minus 6. If you just wrote it as negative times x minus 6, that's fine as well. You don't have to have the -1, actually. It could just be a negative sign. Okay. What cancels?
X minus 6.
Okay. An x minus 6 on bottom cancels with an x minus 6 on top. Remember, if this is 3x, this is 3 times x, and an x on top can cancel with an x on bottom. Okay. So, let's put this together for our final answer. On top, what remains?
3.
1 times 3, which is 3. On bottom, what remains? There's an x plus 9, and there's a -1, which you can write -1. I'm not sure Savas would want a -1. Okay. But more officially, just a negative out front is best. I don't know. Savas, I could see Savas counting you wrong, I guess, but That's what we're looking for final answer. I would not distribute that negative n. Okay, like we haven't distributed anything else back together. We haven't done any multiplying back together. I would just leave it as is. Okay, let's talk restrictions. And again, I know we've done restrictions on every single problem today. I don't think homework has restrictions on every single problem. But, okay. Again, remember, it's any original and new denominators equal to 0. What do you see that we're going to include? I'd probably look at this line to get me started, and I see what? X. I see x plus 9. Negative 1 is just a number. I don't need to worry about just saying numbers. I just need to use variables. X minus 6. Okay. Now, where else do I need to look? What was originally in the denominator that got flipped? 3x squared minus 18x was originally in the denominator and got flipped, yes? What did that 3x squared minus 18x become? It became that right there when it got factored, yes? So the other pieces technically would be setting 3x equal to 0 and x minus 6 equal to 0. In all reality, did those end up mattering again? They didn't, because you already had x minus 6, so that's not going to matter. 3x equals 0 is going to be the same as what? X equals 0. So they ended up not mattering, but do you still need to check? Yes, because sometimes they will matter. Okay? So what are my restrictions? X cannot equal what? The 0. If it's x plus 9, subtract 9, so negative 9. If it's x minus 6, add 6. And so x cannot equal 6. Okay? Okay, questions? Okay, let's do one more division. You ready? What's step 1? Going to keep the first fraction, change division to multiplication, and flip the second fraction. Okay. This one doesn't look too bad. What do we have in the way of factoring? Okay. 2 and 12 both divide by 2. Both terms have at least an x to the first, so GCF of 2x. 2x squared divided by 2x is x, minus 12x divided by 2x is 6. What about x plus 5? It's x plus 5. What about this x plus 5? It's x plus 5. What about x minus 6? Those are all pieces that the only thing we could do is talk about GCF of 1. What cancels?
X plus 5. And x minus 6.
Leaving me with?
2x.
Okay. And we could say 2x over 1 if you want, but if there's nothing in the denominator, just 2x. Now, if there's nothing in the numerator, the 1 would matter, yes? Okay. What about restrictions? Factor denominators, so x plus 5 equals 0, x minus 6 equals 0. What else do I need to consider?
X plus 5.
Yeah, what was originally in that denominator? X plus 5. Sorry, I didn't get you guys a good example of one where it does truly matter, but I promise it does matter at times. So yeah, the repeat X plus 5 doesn't matter, but X cannot equal, subtract the 5 over, that's negative 5, add the 6 over, that's positive 6. So X cannot equal negative 5 or positive 6. Okay? Pay attention for division problems so you remember to keep change flip. Other than that, it's all about factoring and canceling. Okay? You have some work time. Use it. If you need to get 4-1 and 4-2 finished, do that. I will say those scores just went in the grade book this morning.